Hello and welcome to today's lesson on the standard normal distribution and the use of the empirical rule to find probabilities using the standard normal distribution. Now, the benefits of the standard normal distribution, almost all values that are taken statistically end up fitting into the standard normal distribution. If you think about individuals' heights, weights, GPAs, ACT scores. Okay, most data that's collected fits into what we call the standard normal distribution. What we do is we center it at 0, because then when we start talking in directional values and a measurement of what we call standard deviation, which we calculated yesterday. Okay, we use those standard deviations with our mean values to spread out and create this distribution. Okay, the advantage of the distribution is it fits any situation that is normally distributed. And then we have what we call the empirical rule that tells us 68% of all data is within one standard deviation of average. 95% of all data is within 2 standard deviations of average, and 99.7, almost all of your data values are within plus or minus 3 standard deviations of average. Okay, to give you another example of the normal distribution, okay, if we're picking a large amount of oranges, okay, all the oranges are going to be different weights, different sizes. But what happens is when we look at the oranges overall, they will fit this distribution. Okay, we will have a few that are very large. We will have a few that are very small. But most of the oranges will fit right in this 68% plus or minus one standard deviation from average. So the fact that we have this empirical rule in the normal distribution allows us to find situations, find probabilities, and work with them in a fairly quick manner overall. Okay, so now remember, we're using this as a point of symmetry and a measurement of spread. So what we can do is we can start breaking pieces up from that rule of 68, 95, 99.7, and we can use that to build our data distribution and work from there. So now I always suggest using the distribution starting with what we know. Our mean value is 27, so that becomes our center, and we're going to count out in both directions based on the standard deviation distance. So I'm going to load my calculator with the value of 27. I've got my standard deviation of 1.6, so I'm going to start subtracting 1.6's. Okay, now I'm down to 25.4. Now I'm down to 23.8. And now I'm finally down to 22.2. So I have subtracted 3 standard deviations, subtracted 2 standard deviations, and subtracted 1 standard deviation. And I can do the same thing on the high side. Okay, start with my average and load that for an enter. And I'm using basically a recursive sequence here. And I'm adding my standard deviation of 1.6, 1 time, 2 times, 3 times, okay, to get the values of 1 standard deviation above average, 2 standard deviations above average, and 3 standard deviations above average. So you know that if you scoop 1 cup of Lucky Charms, okay, the amount of marshmallows you're going to get are going to be somewhere between 22 and 32, almost 100% of the time. Now, the good news is, to answer the questions that we have here, all we have to do is remember that this is average, and if we're adding or subtracting standard deviations, plus 1 standard deviation is just 28.6. We're moving up 1. The minus 2, 23.8. We subtracted 2 standard deviations from average. Minus 3 standard deviations from average, 22.2. and then plus 2 standard deviations from average, 30.2. Okay, so we use this as a measurement tool, and the measurement tool can help us find probabilities based on the normal distribution. So now what we've done here is we've broken it up into individual parts. Notice that these two pieces add up to the 68%. Okay, if I start on this outside, 2 standard deviations up in either direction. 68 plus 13.5 plus 13.5 gets me to 95% of the distribution. Okay, and then if I work my way all the way out, 3 standard deviations in either direction, we can see that those add up to 99.7% of the distribution. Okay, with the last little bit falling in those outside tails. So now we can use these marker points and this distribution to allow us to solve questions. So if we look at this scenario, shoulder measurements of professional football players are normally distributed, average distance of 95 centimeters, standard deviation of 8. So what we want to do is we want to build our distribution. Okay, centered at 95, and then we just start subtracting 8. 87. Okay, so we're subtracting 8 from that 95. We subtract 8 again, 79. Subtract 8 again, 71. On the upper end, we're going to add 8. 103, 111, 119. Okay, now we can use this distribution to answer any of these questions. Find the percentage of football players with shoulder measurements between 87 and 103. Well, here's my 87, here's my 103. I'm covering 2 areas, so then I just add those percentages together. 34 plus 34 equals 68%. Okay, find the percentage of being between 103 and 111. Okay, we're just finding our endpoints. Here's 103, here's 111. I want the probability of being in that range, so it is 13.5%. Okay, find the percentage being between 87 and 111. So now I'm going to come down here for my starting point, okay, and I want everything between these two, okay, and as I go past it, I need to add it all together. So I've got 34 plus 34 plus 13.5, 68, 78, 81.5% of all players are in that value. And then our last one, percentage below 79. So we're finishing up that value. Okay, I look at my 79, which is right here. I've got 2 values that I go past. So I'm going to add those pieces together to get my value of 2.5%. Okay, so now that is a quick overview of the normal distribution, how we can fit distributions to the normal distribution, and how we can use the empirical rule to solve for probabilities. Thank you and have a good day.